Welcome to session 2 of Rhythm Interventions Online 2022. During this session, the focus is pulse field and radiofrequency ablation of atrial fibrillation using novel focal lattice tip catheters with zero fluoroscopy. The case was recorded very recently with Devi Nair at St. Bernard's Heart and Vascular Center in Arkansas, US, and I'm delighted that Devi can join us today. And I'd also like to welcome a new panel for the session. We're joined by Melanie Govardene from Hamburg in Germany and Roland Tiltz in Lübeck in Germany. Thanks for joining us, guys.
Hi, thanks for having us.
Hello.
So,
Lübeck.
Brilliant. So we've divided the case into 4 parts. So, Devi, I think you're going to give us a presentation and then talk us through the case. Is that right? So I think we've lost your sound, I think, Devi. So I'll keep winging it until we have you back. So what I'll do is during the case, we'll try and bring the audience and the panel in to give us some comments on the case, and feel free to interrupt panel if you want to ask a question. Devi, do you want to test your sound again and see whether we can hear you?
Yes. Is it better?
Got you. Yes. Phew, what a relief.
Thank you.
Over to you, Devi.
All right. Well, thank you, Richard. I am truly honored to be here at Rio with the Rio family again for the 3rd year in a row. And I'll wait for the intro. Can I please have the slides first, please? Thank you very much. So my goal today is to show a recently recorded case of atrial fibrillation ablation using pulse field and radiofrequency ablation using a novel focal lattice tip catheter with zero fluoroscopy, and that means no lead. And let's see, these are my disclosures. But I just wanted to introduce the technology real quick before we got into it. The ablation technology includes a lattice tip ablation catheter, which is a Sphere 9 catheter. It comes along with the high current radiofrequency and pulse field generators, the Hexagen and the Hexapulse generator. It has a peristaltic saline infusion pump and integrated electroanatomic mapping system, the HexaMap, using the Prism One software. The catheter as such...
Devi, they're not, I can't... Sorry, Devi, I can't see your slides. Can we get the Rio team to just show the slides, or are we having a technical problem?
I'll wait until they get it back together.
Yeah, I think so. They're just going to. Apparently, the audience can see them. I just can't. So sorry, Devi. You carry on and ignore me. I apologize.
Okay. Well, that's all right. No worries. You're a master at this, so it'll be all right. So the catheter is a 7 French bidirectional deflectable catheter. It has an expandable 9mm nitinol lattice electrode catheter that has 9 mini electrodes. And the 9 mini electrodes sit on the spherical surface. The lattice tip contains a central indifferent electrode that does not come in contact with the tissue, and 2 additional ring electrodes that are located proximally on the shaft. Now, let's just get into the next one. If you think about, the way I look at this catheter and what the role of this catheter is, since the advent of catheter ablation, we know point-by-point catheters have taken a major lead in AF ablations, and we've seen a lot of advances in technology, including saline irrigation, tissue contact force sensing, and surface thermocouples. There's also been technologies with single-shot PVIs, whether it's RF, cryo, or PFA, but all of these single-shot technologies do not give you the chance to have a flexible lesion set. And I think that's where the Sphere 9 catheter probably will play a role. The compressible 9mm lattice electrode trip, it can perform rapid point-by-point RF and PF ablation. And in that way, you can actually do a very customizable lesion set if you need to. And regarding the system as such, as I told you, it is a dual generator design. So it has both the RF generator and the PF generator, which allows for switching between RF and PF without actually having to remove a catheter or switching cables, and allow you to use the same map throughout the entire case. So very easy to kind of navigate through the actual case. So let's go to the first video. So for ease of things, we have kind of divided the entire case into 4 videos. And we'll start our first session with just how we do our transeptal, a little bit on catheter preparation and the mapping. And here you can see we start our axis. Again, we do all of our procedure under general anesthesia for AF ablations, and that's just universal in our lab. We usually, for this procedure, get about 3 venous axes in the right femoral vein. They're all under ultrasound guided, again, mainly to avoid any kind of vascular complications. The ICE catheter is what helps us navigate within the heart without having to use any fluoroscopy. We do use a decapolar catheter in the CS for pacing and any kind of other needs. You can see we're moving in with the ICE catheter here. You can see the wire kind of going into the superior vena cava. We rule out any kind of intracardiac thrombus, LA thrombus using ICE. Our patients come on uninterrupted oral anticoagulation. You can see we'll advance for this procedure, for using the Lattice tip, we're using a Agilis deflectable sheath. So you can see me advancing the Agilis sheath here. And you'll see on intracardiac echo, the Agilis sheath coming into the superior vena cava. And so this is our technique to do a zero-fluoroscopy or no-lead transeptal by visualizing the catheter and the wire going into the SVC. We're using an RF needle with Baylis for this transeptal. And it's an NRG needle that we have inserted into the Agilis. And we're under visualization, you can see we're pulling the system back, trying to get kind of I would say mid transeptal in this case. You really don't have to be inferior since we have a deflectable sheath. You can see we're with the Baylis technology, you don't really have to tent a lot. We delivered RF, we came transeptal, and here you can see us advancing the Agilis sheath into the left atrium. The sheath obviously will go on full irrigation at this point. We do give heparin prior to our transeptal, and usually try to maintain an ACT goal of about 350 to 400. You can see the catheter being prepped here, and it's very important to de-air this catheter because it's a Lattice catheter, and so we de-air it under saline and make sure that the system is ready. And once the system is ready, we'll get in with the catheter. What you're seeing here is me trying to put in a CS catheter, and I'm doing it under ICE guidance. Currently, the CS catheter cannot be visualized on the Hexa map. I'm hoping that in the future we have a nav-enabled catheter that can be visualized on this mapping system. But currently, I put my ICE catheter under, my CS catheter under ICE guidance, and you can see the CS here with the CS catheter in it. Here we have introduced the Lattice sphere catheter. You can see it's very well visualized under ICE. Routinely, I'll put ICE catheter into the LA, but in these cases, I've stayed in the right atrium for my ablation. We have started mapping. And I think one of the beauties, the way I look at it, is you can see as we're doing what we call a vein mapping. So the catheter actually allows for a very rapid acquisition of not just the anatomical map, but also voltage and activation at the same time. So it's a very quick map. In this case, I think we acquired about probably closer to like 4,000 points in like 5 minutes. They have what's called a vein tool that they use to clearly identify the antrum. I'll also use ICE to make sure that that I have contact and that I have that I'm clearly defining the antrum based off of the eyes as well. So this is a quick acquisition of a pre-map. You can see the patient came in sinus rhythm. We're pacing from the CS at about 600 milliseconds, and mainly to just get a rapid acquisition of the map. Clearly, once we create a shell and create the map, one of the things that we will actually do is, you'll see us do this pretty quickly, is come into the right superior pulmonary vein and try to identify if we can maybe identify where the phrenic nerve is, or what the proximity of the phrenic nerve is to the right superior. Here you can see us pacing from the lattice catheter, and we are in the right superior vein. I'll go pretty deep in the vein, come back into the antrum. You'll see me going to the carina. We'll try to kind of locate the phrenic nerve and see how proximal it is. And if I'm able to locate where the catheter is, or where the phrenic is, then I'll direct my antral lesions farther away from it, and I feel comfortable using RF in that area. But if I cannot tag phrenic, in this case, we were not able to really tag any phrenic, and because we were not able to, I guess my plan would be to just use PF technology along that path. And I think that's, to me, that was the beauty of the system, is you can toggle between RF and PF during the case. Just for full disclosure, the catheter is not commercially available in the US. It is only available through the Sphere 9 persistent AF trial. So this is a persistent AF patient. He was a gentleman who had failed antiarrhythmic therapy, was finally cardioverted on amiodarone, and was here for the ablation as part of the persistent AF Sphere trial. I think the study is almost finishing completion within the next 1 or 2 weeks, and hopefully we'll have long-term results within a year. So, Richard, I'll stop there, and I'll take any questions on this first segment of the video before we move on to the next one.
All right, well, let me quickly start, Devi. I noticed there was a little bit of deletion of the geometry. Do you have to sort of modify the geometry when you're collecting it very much, or is that respiratory that's causing that?
So it is respiratory gated, but the mapping team can kind of simultaneously edit the map if we need to, if there's any over, I guess, collection of map, they can automatically kind of take care of it as I'm mapping. So I'm not really waiting on them to really do any map adjustments.
And I notice, I'm going to ask Melanie about this, because I noticed that I know that you're very keen on not wearing leads and not using fluoroscopy. Melanie, do you select your technologies according to try and avoid leads and using fluoroscopy? Is that something that is a big issue for you?
Personally, I think this is really elegant, and so congratulations on that first, I want to say. But also, unfortunately for me, it's not a case because we have to use fluoroscopy. The thing is that the reimbursement in Germany is difficult. So unfortunately, there's no ICE for me when I do my procedures. But I think that it's very elegant how you handled the situation, also placing the CS catheter non-fluoroscopy, without fluoroscopy. So, but yeah, I think this is really important. And yeah, congratulations on this. Can I ask a question regarding the map?
Please.
Yes? Okay, so I saw that the map was a little bit spotted. You said it's a persistent patient. I also read a little bit about the catheter that you're using. As you said, it's not commercially available. Unfortunately, I haven't used it yet, but I read that you also use impedance guidance for the mapping, so to clarify if you have contact. So my question is, when looking at this anatomy, is it true low voltage, intermediate voltage areas, or is it just that because you said you're mapping so quickly within 5 minutes, that is due to a lack of contact at those areas?
So I think it's a great question, and thank you for the kind comments about the fluoroscopy. I think it's a lifestyle issue here. I think I'm just trying to save my back, is how I'd say it. So, and we are obviously fortunate to be able to use ICE, and so I'll take that. Having said that, coming back to the map, the map is collected. There are 9 mini electrodes, and the map is collected between the EGMs are configured between the mini electrodes and the center electrode, and the normal atrial electrogram amplitude is defined as for at least for this map was over 1.0 millivolts, and the range is 0.1 to 1. And so, having said that, you're right. We are using local impedance from these mini electrodes to a certain contact, and the large footprint of the catheter, it's a 9 millimeter catheter, allows you to get quick map acquisition. And I don't think if you do have to do, so I've had cases where patients have been in arrhythmias, flutters, such, and then you can actually spend a little more time. This was a sinus rhythm map, mainly an anatomical map that we were doing, and it was going to be an anatomical based ablation in this case.
And I saw that you were using the RF needle, and I just wanted to ask Roland about this, because this is, the transeptal is the bit of the procedure that most of the audience are terrified of. Roland, what's your approach to doing a transeptal puncture?
So what we use we use the German way. The German way is we use the CS catheter actually for PFA procedures. We now have a simplified approach where we only puncture one single vein. We don't even use a CS catheter and just do the transeptal fluoroscopy guided with contrast. So that's a very, without TE, without ICE. As Melanie said, the ICE is not reimbursed. And to protect us from the fluoroscopy, we use the zero gravity, which also allows you to get not to get exposed to fluoroscopy exposure. But may I ask you a brief question concerning the technology? So I have seen that you pace the phrenic nerve. Why do you pace the phrenic nerve if you do focal ablation? Because if you do a conventional RF-based PVI procedure, you probably wouldn't pace the phrenic nerve. So why do you pace, number one? And the second question is, how do you choose whether you use PFA or RF? I think RF is a very powerful technology. So why don't you just burn the entire circuit with pulse field ablation?
Well, let me interrupt before you interrupt before you answer, Devi, because I think your part two, you could probably talk to that in your part two of the video. So why don't we go on to part two, and why don't you answer that question while you're showing us that?
Sounds great. All right, so I think in this section of the case, we'll show you how we acquire PVI. So we actually do our PVI. We do the ipsilateral pulmonary veins pairs, and we isolate them circumferentially as one unit. And to answer the question, you can see I'm starting in the inferior aspect of the left inferior pulmonary vein, inferior posterior aspect. The green lesions for me are PF lesions. So to answer the question that you asked before, Dr. Teds, it's if there is proximity to the esophagus, we're sticking to PF in those situations. And on the top of the map here, you can see there's also a pretty well denotation of whether it's posterior, whether it's or anterior, but MAU, it's pretty clear that I'm going along the posterior wall of the LA, and anything that's posterior wall will kind of use PF. And you can see that the lesions are, the PF lesions are 4 seconds each. So very quick lesions as well. And at some point, I think during this video, I'll be able to show you kind of the differences of how you know that you're on a PF and RF. I'm actually using a pedal. So I'll stay on the pedal as each lesion is being delivered. So it's just for 4 seconds, and it automatically comes off at 4 seconds. Over here on the top, it'll show me that I'm doing PF as well. And you can also see I can assess the contact based off of local impedance off of the electrodes. I'm also looking on ICE here to make sure I have adequate contact. In addition, you know that the lesion is adequate or not based off of the temperature response that you get. Obviously with PF, you're not going to get a large temperature response, but you'll still see some temperature response. And then that's how you know that you've given a good lesion. I do like to stack my lesions. You can clearly see that I'm stacking them, and mostly because I do, it's a larger lesion set, and I like to make sure that I'm covering them pretty well. Now you'll see me doing PF along the anterior ridge as well. Along the left inferior pulmonary vein, I like to use PF because the catheter is 9 millimeters, and I worry that if I do use RF, there might be some heat that could potentially affect the esophagus. So you'll see me using PF along that anterior inferior aspect of the left inferior as well. Again, I'm using the steerable sheath quite a bit. It's a very flexible catheter. It is bidirectional, but I do think that you really have to use that steerable sheath to give you stability to give those lesions. Since the lesions are extremely short duration, it's not that hard, but still you can see this ridge was pretty slippery, and we were having a little bit of challenge with that, even with the steerable sheath in there. But still overlapping lesions, kind of bringing it together. Now, coming back to your question on why not just use RF all along, I think for me, the way I look at it is if there are, say, thicker tissues that I see on intracardiac echo, for example, if I see that the ridge is extremely thick, or then I like to use RF to get probably a much deeper lesion. You can see on this ice here that superior limbus, that septum, is relatively a little bit more thicker. And so that was one of the reasons why we were actually looking to see if we could ablate along the anterior septum with RF rather than just use PF. But in this case, you'll see us use PF. So I'm actually switching to RF here. And you can see the lesions are denoted as red. And on the top here, you can see I'm using RF. RF lesions are 5 seconds. And you'll definitely, again, the same way the RF energy emanates from the entire lattice framework, and it creates a kind of a uniform current cloud. The generator really employs a temperature controlled mode. You can get up to 73 degrees Celsius. So, and it can modulate the current output based off of the hardest thermocouple. So it'll automatically come off at 5 seconds. And I think we'll come on video, come on audio here as well from the case. You'll clearly see the audio cue as well. There's a definite difference between the sounds that comes out. With the RF, there's a particular sound, and with PF, there's a different sound, and we might not have put the video there. But anyway, so there's clear ways of knowing whether you are using RF or PF, and you can easily toggle between the two. And I think I had mentioned this before about the generators, because it's a single kind of generator. You can toggle between back and forth without having to change any cables or change any catheters. You can use the same map for it and move on with the case. And it's a double tap on the pedal to go between RF and PF. Or I can just tell the clinical to kind of switch between RF and PF. And you can always confirm whether you're using PF or RF based off of what you see on the top of that map here. You can see I've moved on to the right side. Just from a time standpoint, it took us about 4.5 minutes to do the left PVI. And mostly because of that challenge within the anterior ridge. But most of the time, I would say in the cases that we've done, we've had about, I would say, closer to 25 plus cases. I would say the average PVI time, total PVI times have ranged between 8 to 10 minutes. You can see we're doing the posterior aspect of the right veins, again taking the right pair in one circumferential format. I've not really had to do any antral ablations with this catheter. We've been able to get first pass isolation. But having said that, if you do have any concerns, if you do your single or circumferential lesion set and you do not get your isolation, you do have the capability of going and quickly mapping to see where the breakthrough is if you needed to, since it can give you voltage and activation map and anatomy simultaneously. So here you can see us moving along that posterior inferior and posterior superior aspect of the right veins. I'll stay usually based off of eyes. I like to use eyes to decide where the antrum is most of the time. And in this case, as part of the study protocol mandate, you would see us doing a posterior wall lesion set as well. Obviously, we can talk a lot about what lesion sets need to be used in a persistent case, but for this study protocol, there is some posterior wall ablation as well that's performed. You can see us here in the video coming along the anterior aspect of the right inferior vein. And these are pretty thin areas, so I continue to use PF here. I think in the early European study, when they were doing dosing studies, there was a strategy of using just PF all over, like PF everywhere, or you could choose between PF and RF, and you could just use RF all over the, along the anterior wall if you needed to. But I've kind of stuck to PF most of the lesion sets, and then using RF in the case of the anterior left ridge and along the anterior right, I would say septum, along the anterior antrum of the right superior pulmonary vein, if I'm able to localize phrenic. Now, I almost always do phrenic pacing for all of my RF ablations, and I try to kind of define the antrum and phrenic proximity in most cases. In this case, because the footprint of the device is large and there's such a big heat sink with RF, I'd like to see if there is, if I can tag phrenic first. If I can tag phrenic, then I feel comfortable using RF along that path. But otherwise, I stick to just using PF. And like you said, you could just use PF and be fine. But you can clearly see on eyes here, I'm ablating that very thick anterior septum. So you'll see me do multiple overlapping lesions. If it was RF, I don't do as many overlapping lesions. I just do just adjacent lesions for RF. Whereas if it's a thicker tissue, I do more overlapping lesions with the PF technology. So we are kind of coming along the along the roof. Now, most of the time we use very low tidal volumes. That is our standard of care for most RF or focal ablations. And when we get to the roof, especially the right antral roof, we actually go even lower, probably closer to like 250 to 300 cc's on the tidal volume, and increase our respiratory rates to get better catheter stability in these areas. And that's just our standard of care for other focal ablations as well. And that's kind of what we have used in this case as well. And once it's done, we will quickly check with the focal catheter whether we have isolation, and we'll do a full map later on. And I'll stop here and we'll go to maybe take some questions before we move to the next video.
Yeah, great, Devi, really superb. Tell me about your confidence about knowing, I mean, I really love seeing the pulmonary veins delay and then isolate. And I guess I'd kind of miss not seeing that in real time. Are you watching the signals as you do the ablation? Do they give you enough to tell you that something's happening?
So even for my focal RF ablations, I use a single transeptal approach. And I don't get to see it. I used to do double transeptal and have a mapping catheter in the pulmonary vein and watch for isolation as I was doing point by point ablations before, but I've moved to a single transeptal approach. So I tend to do my lesion set and look for first pass isolation. That's has been my practice. But having said that, you could have a catheter in there if you wanted to. The PF catheter, as you're doing PF, there's such a large electrical current there that you lose the signals. Obviously, you can go into the vein and map very quickly if you want to, but it's 4 minutes per per pair or per lesion set. That it was almost 8 to 9 minutes for the entire PVI. That it really doesn't. I don't stop and look for it. I'll do my entire lesion set and then do a map after.
Let me ask Roland, do you use a single puncture, Roland, in?
So only for PFA cases, we use a single puncture. We give atropine before because all patients have a vagal response. But so only for PFA cases, we do a single venous puncture. For cryo procedures, we also puncture the vein twice because of the CS catheter and for phrenic nerve pacing. And for RF-based procedures, we puncture the vein 3 times because we always do a double transeptal. We want to see real-time isolation.
And Melanie, what's your approach to looking at and monitoring pulmonary vein signals? Do you do that during your ablation?
Yes, to be honest, I'm with you there. I like to see it and I like to see what I'm doing. So I guess with cryo, sure, you can see the real times with the a spiral catheter. With RF also, we would use a ultra high density mapping catheter as well. We only do 1 transeptal puncture, but we cross this 1 puncture site with 2 sheets. So we have 2 catheters in the LA. And with PFA, we use, depending on our study protocol that we are using, either we do high density maps if we, for example, ablate complex atrial tachycardias with PFA. If we just do the pulmonary veins, we are fine to check it with the basket shape of the multispline PFA catheter that we are using. You kind of have to know that the electrodes are a bit larger, so you see a lot of far field, and you kind of need to get used to it and get a feeling about what is far field and what is the true potential. So this can be a bit more difficult, and I would recommend maybe when starting at using a map, just so you have a feeling what the signals are. But I had actually exactly the same question about this, and just the question for me is that you say you check the veins when you do the remap, but for this, just because the catheter is a bit smaller than the PV ostium, you would really have to have contact around the whole ostium, right? Because otherwise you could maybe miss a gap when you don't have contact. So have you noticed this, that it's important to really like precisely map the antrum afterwards to not miss the gap? Or can you maybe tell us a little bit about this gap mapping?
Absolutely. Yeah, it's true. So especially when you're doing a single catheter and not really watching for isolation, it is very imperative that you do a very dense post-map. And the protocol also requires for a 20-minute wait or a adenosine challenge. So we do actually do that at the end, and we do have a post-mapping. I think it comes in the next video, but we will do a dense map along the antrum to make sure that there is no reconnection. We'll actually do a dense map within the veins. We do entrance and exit block from the veins and along the antrum. So we'll pace with the lattice tip along the entire antrum to make sure that there is entrance and exit block. So we will take our time, during the post-mapping period to confirm that we do have isolation. Yes.
So I'm going to ask you a question, Devi, and then open it up to Melanie and Roland. This catheter looks pretty passive. It looks pretty forgiving. Is your impression that it's a pretty soft and easy catheter to use? I mean, what's the chance of you causing harm with it?
I mean, I will say that it is probably, it is probably one of the most compressible catheters that I've seen. I think the catheter stability that you get is achieved because of the compressibility of that lattice mesh. And it's got like the spring-like interaction with the tissue. So I think that with the topography of this catheter with the big footprint is what I think gives you the good lesion sets and gives you the good contact. But I don't feel like I'm as worried about causing a perforation or anything with this catheter, just because of its compressible nature.
And I also get the impression, and I'm getting this message from Roland and Melanie as well, that you all feel that PFA is less traumatic and less risky. You're using, anytime you're worried, you're using PFA rather than RF. Is that supported by evidence now, or is this still yet to be determined?
For
I'll ask you
us,
first,
PF
Debbie.
catheters. Sorry, I was saying that, for us, PF catheters are still in clinical trials, but I do think that there is enough data to show tissue selectivity, especially from all the work that's being done in Europe. So for me, I think the fact that you can do this without actually worrying about the esophagus. And just to full disclosure, we do not have a temperature probe in the esophagus in this case. And I wouldn't dare do a focal RF ablation without having some kind of temperature monitoring in the esophagus or some kind of, esophageal, deviation tool. So for me, that is a big deal. And phrenic nerve is another big deal. So I think for me, those are the two big things that would direct me towards PF.
And Melanie, what's your thoughts about your?
So I agree on the point. Yeah, totally. I agree on the esophageal issue. I think that if you can avoid a life-threatening complication, you should as a doctor, and an elective procedure as AF ablation. Unfortunately, we don't have the data yet supporting more than symptom control. But to be honest, I think I'm super excited about PFA, but I think there's still a lot that we need to understand and that we don't know yet. So do we really have data that is, for example, more efficient? Is it only the safety that we are going for, that we say it's more safe, so we would use this? Or do we also want to be as efficient? And I think we are not finally there yet. Everything seems promising and good looking, but I think there are still some questions. And what for me as a physician and as an electrophysiologist is important, I would like to have some control. And about PFA, we get like a waveform we get to use. And do we really know exactly what is going on? And I still feel like there's a lot we need to learn. So with the multi-spline catheter, we're taught that we need a lot of applications to overlap. Now, Devi showed us the case where she says she stays 4 seconds on one spot and then she moves on. So I think this is, for example, interesting. It's both PFA technology, but with one you would need overlap. With the waveform of the lattice tip catheter, you probably don't need as much at the same location. So I'm really curious about the chronic lesions that we'll see in the future of those different PFA approaches. And also one thing I was interested about is, are there any coronary spasms that you can see with this technology, or is it waveform dependent maybe? So I think I'm cautiously optimistic. That's how I would say it. But I think we should still, there's so millions of people that have been treated with their AF, and we're not up there to this number with PFA yet.
Well, and Roland, is your feeling you're feeling very confident about PFA?
So basically, at first I have to highlight that I'm a very big fan of pulse field ablation. So there's definitely some bias. However, I also know from different animal experiments that it's still not the holy grail. And if you deliver excessive high energy with pulse field ablation, you can still get a lot of collateral damage. I think this is something what we have to keep in mind. In addition, everyone says it's non-thermal. We monitored the esophagus in patients undergoing pulse field ablation procedures, and we got temperature of up to 41 degrees with pulse field ablation. So in most cases, the temperature rise is only minimum, but you still can measure temperature up to 41 degrees if you deliver pulse field ablation energy in the left atrium. And I think the other thing what we have to keep in mind is like the border zone. The border zone of pulse field ablation is much larger as compared to RF lesions. So there's still many aspects that we have to keep in mind if we use this technology, even though, again, I think we have to understand it better, but I'm convinced it's going to be the future of ablation.
Okay, great. Good points. So the audience has said, I don't see any real advantages for first do PVI using Catheter compared to other single shot devices. The learning curve is probably much higher than in cryo or PFA. But Devi, in part 3, you're going to show us why you're using this rather than a cryo. So why don't you go on to the posterior wall isolation?
Sure, let's do that. Okay, so in this, let's get to the next segment on the video, please. All right. So for this case, as it was part of the PERSIST AF sphere study, we actually are doing a posterior wall isolation as well. So I'm going to start with what Dr. Schilling just mentioned. You know, I mean, why would you want to use a focal catheter to do AF ablation anymore? I think the fact that you take a focal, a single shot PVI catheter, you don't have the flexibility to create additional lesion sets that you need. If your patient converts into a different flutter or atrial tachycardia, to be able to rapidly map and do, I would say, more catered lesion sets, you do need to have a focal catheter, and to not have to pull in multiple catheters. So if I'm doing a cryo case and my patient goes into a flutter, or if I want to do a posterior wall isolation, I'm usually taking an RF catheter out, and that's not really a cost-effective, financially feasible way to do things. And so here you can see us doing the inferior wall of the posterior LA. Again, about maybe 5 or 6 lesions here because of the large footprint of the catheter. The posterior wall isolations are pretty quick when it comes to actually getting the lesion sets done. I've not really had to do a lot of, I would say, scatter ablation through the posterior wall. I've been able to isolate the posterior wall with just an inferior line and a roof line. You'll see me going to create a roof line in this case. There are many operators that actually just perform just a roof line alone to prevent any kind of atypical flutters from the LA. Like the previous, the previous video, whether we're doing antral ablation or whether we're doing linear ablations, I think it's very important to make sure that we have contiguous lesion sets and that there's no breakthroughs. And so we'll finish our posterior wall lesion set and then go on to post mapping to make sure that we have adequate I would say isolation of not only the pulmonary veins, but also the posterior wall in this case. The Sphere 9 PERSIST study, currently it's a randomized study, and randomized 1-to-1 randomization between the Sphere catheter and the Thermocool SF catheter. And so it is actually partially blinded, so the patient is not aware which therapy they got. Obviously, the physician is aware. So hopefully, we'll get some randomized data, and it's a non-inferiority trial looking at safety and efficacy. So in this case, the post mapping is actually a more detailed map. We actually spend more time doing the post map because we're not just acquiring anatomy. We're looking at voltage. The array of the mini electrodes on the lattice tip will allow us to get like rapid electrogram acquisition, and if you have to pace, you can check for entrance exit block as you're mapping. You can pace from the lattice tip from any location. You can even look at the system actually also allows you to do like vector mapping that updates beat to beat on a beat to beat basis. With I would say careful movement, you can identify breakthroughs very easily if you have any. And usually in this, as part of this clinical trial, we and as I mentioned before, we had the mandatory either 20-minute wait or an intravenous adenosine challenge. And usually we use about 24 milligrams of adenosine. So it's a pretty aggressive adenosine challenge. And we'll make sure that we have both entrance and exit block after our adenosine challenge and through our adenosine challenge. And then I think, the question about, how we, as I said, the question about whether the lesion sets are contiguous and if there's any breakthroughs, I think you just have to take your time mapping your lesion sets. And in this case, we did not have any other additional areas in the left atrium that we saw the need to. We do a post LA ablation pacing set before we leave the left atrium to look for any inducible flutters, and it's a quick EP study just to make sure there's no inducible mitral flutter or anything of that sort before we leave. And if there is an inducible mitral flutter, or if the patient comes in atrial fibrillation and goes into a left atrial flutter, then we'll use the Lattice catheter to map the flutter. And I think, to me, that is another beauty of the system, is you're not having to use multiple catheters to do the ablation and mapping. It's a single catheter that helps you kind of gain the map, do the ablation. So less resource utilization in my I guess experience. You can see. I mean, you go ahead, Richard.
Yeah, you seem very. I mean, I find the roof sometimes really painful to block. I guess Bachman's bundle and some thick tissue there. I find it the one that sometimes is the hardest thing, and yet you seem pretty relaxed about PFA and pretty confident it's just going to smash through it. Is that your experience with this technology now?
I mean, again, my experience is limited from the trial. So of the cases that we've done, it has not been challenging, surprisingly. And I agree with you. The roof is always it's a challenge for me too. And I wonder sometimes if it's the catheter stability or if it's the septopulmonary bundle, the epicardial connections, what maybe. But sometimes it is hard to get posterior wall isolation, and we've not really had any issues. Again, we have to wait and see what the durability of this lesion set is. Obviously, in the earlier European trials, they did do mandatory post-mapping, and they saw the durability of the lesions. Whereas in this trial, we're not doing any post or chronic mapping, as I would say. So we'll just have to wait for clinical outcomes and see if we get durable lesions. And if any of these patients come back for redos at that time, I guess we'll have more data on that. But we do get posterior wall isolation pretty quickly. And I mean, you saw how there are like 5 lesions or 6 lesions inferiorly and about 5 lesions superiorly. Took me probably closer to like 3 minutes to do the posterior wall, which is usually not the case with the focal 3.5 millimeter RF catheter.
Yeah, and I'm usually really nervous about doing it because of the esophagus as well, which is obviously something you're not worried about with this.
Yep, exactly.
And that density of the map, it looked pretty smooth. It looked like it was collecting pretty quickly and gave you a very clean, low voltage pattern. Is that true, or is it a feature of the catheter and the electrodes?
I think it's again because of the large footprint of the catheter and simultaneous acquisition of voltage and activation. So when you're doing post mapping, we're doing activation as well as voltage simultaneously to look for breakthroughs. We're looking at vectors to make sure that we don't have any breakthroughs. And as I said, going between mapping, I can stop pacing in the CS and pace on the lattice tip and kind of go back and forth, and really doesn't affect the workflow at all.
And did I interrupt your video, or so the video finished now on this?
Yeah, I know. I think it was mostly just the post mapping and then the pacing, and I think if there are any additional questions from Melanie or Ronald, I'll take that.
Well, I'm going to bring in Roland, because one of the audience has said that the low voltage zone seems to be a bit broader than your lesion set. And Roland was kind of inferring that the sort of collateral damage of PFA was a little bit bigger. That's the case, is it, Roland?
Yes, I mean, what you typically have for a pulse field ablation lesions is a broader border zone with a reversible lesion. I think this is what we always have to keep in mind. And I think this is also the reason why in this live case you mentioned or highlighted that if you deliver pulse field ablation bubbles, the bubbles are closer, you have more overlap as compared to RF lesion. No, that's the idea behind your closer lesion set, isn't it?
That's right.
So I think this is a very important aspect that we have to keep in mind.
And Melanie, you use PFA, that's correct, is it? And which technology have you got experience with?
So yes, we use the multi-spline catheter with the basket and flower shape because it's the only one commercially available at the moment. And so we progressed from just performing PVI, and we also were able to publish a nice paper on ablation of atrial tachycardias with the PFA catheter. And of course, it also has something to do with the catheter design, right? The lesion. So also the lattice tip is 9 millimeters. The pentaspline is also a really big catheter. So maybe we get smaller, better, or like more small lesions if we use a smaller catheter, right? If we want to have a more demarked zone. I wouldn't mind doing a PVI and having a little bit broader antral lesion. I mean, I don't think that this is harmful, right? You should just try to avoid to kind of block the roof by accident. It's something I've heard from a lot of investigators, what happened to them in the beginning. We use actually the PFA catheter in patients undergoing AT ablation that have been undergoing a lot of ablation procedures before. We feel like they failed RF, they failed cryo, they need something else. They have a lot of scarring. So yeah, you could argue that the lesions are broader, but you could also argue that you finally have a tool that is able to block those lesions and to modify the substrate that is really large in those patients.
And Devi, one of the audience has asked a question which I think is particularly pertinent to the US, but around the world, about the speed and efficiency of the procedure. Because I know in the US, reimbursement has been pretty drastically cut in the last few weeks. And so everyone's looking to try and get these procedures done more efficiently, not least because it keeps your waiting list down. What's your feeling about this technology, and how is it as quick as everything else or quicker?
I mean, obviously it's a focal catheter, so you do have the learning curve of, or you have to be able to move the catheter around. But I mean, you'll see the total cases are usually under an hour, and that is including sometimes the protocol mandated wait times and adenosine challenges and all the other requirements that come with the study. The actual PVI times on an average have been like 8 minutes or so. Posterior walls usually a couple minutes. CTI ablations are about a few minutes. So total ablation time is extremely low. Mapping is very quick. And as I said, one of the points that I wanted to make about why not use cryo or something of that sort, the catheter has its own mapping system. So for me, that is an added advantage. It's one system and it does all of it. And so it makes things a little more efficient in my mind, that you can just use the same catheter to map. You don't have to keep bringing catheters in and out of the heart. So I think that adds to safety as well, if you have less exchanges within the heart. So I think, and that cuts down time.
Great. Well, we're running a bit short, so let's go on to your final bit, which is the CTI ablation and phrenic nerve pacing. Can we roll that video for Debbie, please?
Yeah. Thank you. And just as a background, this patient had clinical right atrial flutter. So we did do a CTI lesion set. And you'll see me, I've actually pulled into the right side. I do all of my CTI ablations also under ICE guidance. And you can see me going along the CTI with the catheter. I'm obviously on top of the right coronary. And you'll see me actually using RF. And one of the reasons why I use RF along the CTI is I feel like I want to, if I use pulse field, I'm worried that actually, this is one time I actually like to see the block actually happen. So I pace in the CS and I want to see the block happen. So I don't want to create this large electric field that might not have a full lesion and still get blocked. So I think that's one of my concerns, but also the right coronary is there. And as Melanie mentioned, I'm not very sure about the coronary spasm issue. So I do use RF in that area. Also, that area is a little bit more thicker. So I do use RF. So you'll see me come along. And one of the things that I've watched for is the change in the echogenicity in the heart tissue. And I don't think there's a lot of data on it, but whether it's RF or PF, that's one of the things that we kind of watch for lesion formation. So you'll see how echogenic the tissue gets as we are delivering the lesions. And I'm pacing from the CS, and you'll see as we come along into the end of the eustachian ridge. We now have block. And you talked about efficiency of a CTI line. I think that's as efficient as it gets for a CTI line. It's about 5 lesions. And I think towards the eustachian ridge, in this patient had a very thin eustachian ridge, I already had block. And since I already confirmed that I had block, you'll see me deliver a PF lesion here, and you can see the color changes. I've delivered a PF lesion towards that eustachian ridge. And because of the way that catheter is, you can actually sit at the edge of the eustachian ridge and deliver a pretty good lesion. And you can see me here pacing from the both sides of the line. I have clockwise block here, and I'm now pacing from the lattice catheter. I have counterclockwise block. We'll again map around the line to make sure there's no breakthroughs and the activation is right. And then at this point, I'll reverse the paralytics. And I told you this procedure was done under general anesthesia. The patients could get some skeletal muscle spasm, so we do paralyze them, but we reverse the paralytics, and I'll take the lattice tip catheter into the superior vena cava, and I'll watch it on ice and map and make sure that you can see Michael, my scrub, is actually checking for phrenic as we are pacing from the lattice tip catheter, confirming that we don't have any phrenic nerve injury. And we've not seen any, but again, we continue to do that as part of the trial protocol. So I'll kind of stop with that, and take any kind of final questions so we don't run out of time.
So we've got one question, Devi. Can you select splines or electrodes for the ablation and abandon others?
No, you cannot. So the current is delivered through the entire lattice footprint.
Brilliant. And that's the same for PFA and RF as well?
That's right. The catheter, the contact is based off of the lattice tip, and you can't really select the electrodes. And they're mini electrodes. It would be hard to do it too.
Any final we've got 2 minutes left. So before I wrap up this session, Melanie or Roland, did you have any other observations that you wanted to introduce? Maybe Melanie, do you want to get your hands on this technology now?
Definitely, yes. I think the most advantage is seriously that it's a mapping system and an ablation system, and you can toggle between 2 energy sources. So it kind of has everything you need, and it's super fast. And congratulations on this really, really nice case. I really liked watching this. Thank you.
Thank you.
Roland, any comments that you want to leave us with? Yeah, also congratulations from my side. Fantastic technology and absolutely great case. I also like the design of the catheter. I think it's the soft tip and the big footprint is a wonderful combination, and particularly that you can combine PFA and RF energy. So congratulations to this wonderful case.
I would leave by commenting how outrageous it was that you didn't even bother to create an anatomy for the right atrial isthmus. You just did it with it shows the mastery of your ICE understanding. And I think Michael deserves all the credit for that, because I saw him maneuvering the ICE catheter. So yeah, it was a brilliant example of how you use ICE and know exactly where you are. That was great. Well, thank you so much to Devi and to Melanie and Roland for a wonderful session. We really enjoyed it, and the audience were clearly enjoying it as well. They threw in a lot of questions. The main program will now take a short break, but we have a symposium coming right up. So please stay with us for that. And then after that, you've got a full program for the second half of the day. So see you in a short while.